Hello, this is Garrett Keane. In this video, I'll present the solution to the integration problem which you see here. This equation is a quotient in which the numerator is the quadratic equation 5x squared minus 19x plus 3. The denominator is this linear factor x minus 2 squared multiplied by x plus 1. If you were to multiply this first one out, x minus 2 and square, you will get a quadratic. And then if you multiply that resulting quadratic by the other linear factor x plus 1, you will end up with a cubic equation, the first term of which will be equal to x to the power of 3. As it stands, it is not possible to integrate this equation directly. The correct partial fraction rule must be applied to transform it into smaller quotients which can be integrated using the methods which you've applied previously. In this problem, the denominator of the quotient is a product of two factors, one of which is squared. For this reason, the fifth and last transformation rule should be chosen. Page, we will look at a general solution of these type of problems. The transformation rule from the previous page is transferred over, and the integration operation is applied to each term on both the left-hand side and right-hand side of this equation. Then the next step, the constants a, b, and c, the arbitrary constants, are taken outside the integral signs, and on the second equation, the denominator is brought up on top by changing the plus 2, the squared power there, to minus 2. This equation is now in a format in which it can be integrated. So on the next line, we'll show how each one of these is integrated. The integral of 1 over ax plus b is equal to the log of ax plus b divided by the coefficient of x, which is a. When we go to integrate the second term, the power minus 2 is raised by 1, so 1 is added to it. So this becomes minus 1. You divide by this raised power, and you also divide by the coefficient of x. The third term is similar to the first term, and the integral is equal to c times the log of small c times x plus d divided by the coefficient of x in this case, which is c. And over here on the right-hand side, we have the coefficient of integration, which we call c1, to differentiate it from this arbitrary constant here, c. The last line, just tidy these two, is just to tidy up the second term. In the first term, the small a is taken outside here. That's also on the third term, the same thing is carried out here. And on the second term, we have a minus 1 here, so that's brought outside, and that gives us the minus here. The b, the arbitrary constant b, stays up on top. The a, small a, stays underneath, and the ax plus b is brought down underneath because the power is minus 1. Here we have our problem that we have originally. This is our transformation rule, which we should apply. So if we apply this transformation rule to our problem, we end up with this equation here, where we have our three arbitrary constants, a, b, and c. It is necessary to transform this equation from a series of quotients into products before we can calculate values for the arbitrary constants a, b, and c. This is achieved by multiplying by the denominator every term on the left-hand side and the right-hand side of the equation by the denominator of the left-hand term. This is x minus 2 squared times x plus 1. You can see that it's shown here in red that we multiply across. In the first case, on the left-hand side, of course, these are going to cancel, and you're left just with the numerator on the left-hand side. For the first term on the right hand side, x minus 2 divides into x minus 2 squared once, so we're left with a times x minus 2 times x plus 1. For the second term, we divide x minus 2 squared by x minus 2 squared. Those two terms cancel, and you're left with b times x plus 1. In the third term, the x plus 1 terms will cancel. This term cancels with this one, and you're left with c times x minus 2 squared. We would normally try to start to work out the arbitrary constant a by eliminating b and c. That is not possible in this case because a is multiplied by both factors x minus 2 and x plus 1. So in this case, we look to work out the value of the arbitrary constant b. If you look at the equation, a is multiplied by x minus 2 and c is multiplied by x minus 2. So if we set that x equal to 2, both of these values will go to 0 and b will be the only value. B will be the only constant that's left. You can see here that I've shown the value of 2 in red, and you can see we substitute in 2 everywhere for x. If I go from the left hand side, from over here, 2 squared is 4, 5 times 4 is 20. Minus 19 times 2 gives us minus 38 plus 3. That is multiplied by a, and 2 minus 2 gives us the 0. So you can see straight away that a is going to be eliminated. Here we have 2 plus 1 giving us the 3. We also here have b, and that's multiplied by 2 plus 1, so it's multiplied by 3. And over here we have c is multiplied by 2 minus 2, so c will go to 0 as well. If we evaluate the left hand side, 20 plus 3 is 23, 38 minus 23 is 15, so we have minus 15, and on the right hand side we have 3 times b. So of course we work out b by dividing across by the 3, and b is equal to minus 5. Our next step is to work out the arbitrary constant c. If we look at the formula again, we can see that a is multiplied by x plus 1 and b is multiplied by x plus 1. So if we can get this factor x plus 1 to go to 0, a and b will be eliminated. Of course, we can do that by setting x equal to minus 1. On this line, we see that we plug in minus 1 everywhere for x. So you can see here that if I evaluate it from the left-hand side, minus 1 squared is plus 1 times 5 gives us 5. Minus 19 times minus 1 gives plus 19. And the plus 3 is copied down. That's multiplied by a times minus 3 times 0 plus b times 0 plus c times, and over here we have minus 1 minus 2 gives us minus 3, which we square. So if we add up the left hand side, we get 27, and on the right hand side we have minus 3 squared giving us plus 9. Of course, c is equal to, we divide across by 9, give us c is equal to plus 3. To work out the arbitrary constant a, as I said before, you can't eliminate it since it's multiplied by both factors, but it can now be worked out relatively easy by setting x equal to 0, since b and c are already known. So we have our formula here, and if we plug in x equal to 0, the evaluation of the left-hand side becomes very easy because the x squared term will disappear and the 19x term will disappear. You can see it's shown in red here everywhere where we put in x equal to 0. And then if we evaluate it here, we have 3 on the left-hand side. That is equal to a times minus 2 times plus 1 times b times plus 1 plus c times by minus 2 squared. So if we multiply those out, we end up with the expression 3 is equal to minus 2 times a plus b plus 4c. We're looking for a in this case, so I bring in the b and the c to the other side, and we divide across by the minus 2. So a is equal to 3 minus b minus 4c divided by minus 2. You can then plug in the values we already have for b and c. We know b is minus 5. We know c is plus 3. We plug these values in, and we end up on the right-hand side here with a is equal to 2. In the next step, we've worked out a, b, and c, so we plug those values into our formula, which we worked out previously. You can see that is done here. And the next step, what we do is we take the arbitrary constants, well, the 2, the minus 5, and the 3 outside the integrals, and we also transform the second formula here by bringing the denominator up on top. So as I say, we bring the 2 out, bring the minus 5 out, and we bring this up on top by changing the plus 2 to minus 2. This equation is now in a format that can be integrated. The final steps are to integrate the formulae that we see here, the terms that we see here. The integral of 1 over x minus 2 is the log of x minus 2. On the third term, the integral of 1 over x plus 1 is the log of x plus 1. For the second term, we have x minus 2 to the power of minus 2. So we raise the power of minus 2 by 1, so it becomes minus 1. We divide by the raised power, and we divide by the coefficient of x, which is equal to 1. So it just isn't shown here. The next step we're going to do is to tidy up the second term. So the minus 5 and the minus 5 cancel. It'll become plus 5, and then the x minus 2 to the power of minus 1 is brought underneath because the power is minus 1. In addition, we can simplify the formulae by the basic rule that 2 times the log of x minus 2 is equal to the log of x minus 2 squared. So we can bring the 2 up here as a power, and we do the same thing over here. So we bring the 3 up as a power. We can simplify this equation form. Again, another step. The log of a plus the log of b is equal to the log of a multiplied by b. It's one of the rules of logarithmic functions. And I apply that rule here. And we basically can say that the sum of these two, this one and this one, is equal to the log of the product of the two terms. So this is the final answer where the rules of logarithmics have been used to simplify these two terms, the log terms, into a single log term. Thank you very much for listening. That's the final solution.